How are you, friends? Well, today we're going to introduce one of the most fundamental laws in electricity. After we introduced KCL, today we're going to introduce KVL, which is Kirchoff voltage law. Well, this law states that the algebraic sum of potential difference in a closed circuit loop is equal to 0. Okay? We can have as example here, this is one closed circuit. Okay, this is one closed circuit, and before we come and analyze it, we have to define two concepts which are very important, which is voltage drop and voltage rise. What is the voltage drop? Let's suppose that we have one point here and we have resistance. Okay, let's suppose that the direction of a current is this one, and have positive, from positive to negative. Okay, so if it's coming from high potential to low potential, we will call it negative, and this is what we call voltage drop. Why is a voltage drop? Because we are coming from high potential to a lower potential. That means that there is a drop in the voltage and the potential difference. There's one drop. So suppose we have the opposite situation. Okay, we are coming from negative potential to positive potential. The direction of a current is like this. This we're going to call, it will be positive, and we call it voltage rise. Okay, this is one of the concepts that we're going to use to explain or to clarify this theorem. Let's suppose, or let's assume, that the direction of our current in this circuit is like this. Okay, so this is positive, this is negative, this is positive, this is negative, this is positive, this is negative. And according to Ohm's law, we all know that voltage equals to current times resistance. Okay, so let's start from here and represent the voltage difference across all this closed circuit. Start from positive to negative. This is the direction of the current, so we have drop, and then in this case what will be represented as I minus I R1. Why minus? Is minus because there is a drop in voltage, because we are coming from high potential to lower potential. Similarly, in this case also we are coming from high potential to lower potential, so it will be minus I R2. If you come here, you are coming from high potential to lower potential, but this is a battery voltage. Since it's a battery voltage, we don't multiply it with the current, we just put negative voltage 2. Okay, if we continue our path, coming from low potential to positive potential, so we have plus V1, and according to the statement, this sum should be equal to 0. Okay, so if you reorganize the equation, we're going to have V1 minus V2 equals to I1 R1 plus I R2. Okay, therefore in KVL theorem, the sum of the battery voltage in this case is equal to the sum of voltage drop. This theorem is also called the conservation of energy. Conservation of energy. Why it's called conservation of energy? Since we are working in a closed path, there is no energy loss, so that's why it's called conservation of energy. The energy is conserved. It obeys the law of conservation of energy. This is also one of the basic I repeat, the basic electrical fundamental theorems that is going to be applied to overcome more complicated DC network problems. So in the next class, we are also going to show some theoretical example, how to solve the value of voltage by using KVL. So if you like the video, you know how to do. Press the like button. If you had any doubt, you can just let in the section comment below, and I'll be happy to answer and help. I hope that video gave you some topics or some basic things regarding to that topic. Thanks. See you in the next class.